Press.
Okay, so good afternoon all. So we just dive right in, continue from where we stopped. I noticed in the previous video that my screen was not showing. That's the output of my analysis on my SPSS was not showing. So I would just like to rerun the analysis and then we'll move on from there. So to do that, let me share my SPSS. Okay, so let's open the data we are using. Okay, so I believe my screen is showing. So let's just run the analysis. Okay, so before I do that, I think I just want to share the report so that we'll have an overview of what it looks like again. And this is the report. This is the table showing the variables, age, level of education, marital status, the frequency, and their percentages. So we are going to see how we got this using SPSS. So let's go back to our SPSS. Okay, so we'll go to analyze descriptive statistics, frequencies, and then let's start with level of education. We click on level of education, we move it inside this box, then you can look at the statistics and then you see that we have mean, median, mode, sum, quartiles, and a whole lot of things, but we are not doing these descriptives now. Right now, we just want the frequencies and then the percentages. So since we are not using this, we just say continue, and then we want our frequency tables to show. So if your frequency table is unmarked, you click on it, it shows a good, like a ticked sign, and then you press OK, and then the output shows my output. Okay, yeah, my output is showing now, and then here it's just simply telling us that 42% had no formal education, and 28% in percentage is 28%, valid percent is still 28%. So this valid percent comes in handy when we have a missing data. So right now we don't have any missing data. Say we have 4 missing data, instead of choosing our percent, that's this column, we use our valid percent instead. But then since we don't have any missing data, our percent and our valid percent, they are all the same. Okay, so we want to carry out the descriptives of marital status. We click on marital status, put it inside the box. Our frequency table is already ticked. Okay, and here it is. Our marital status is showing that 35 persons are divorced, percent 23.3, 5%, 23.3, married, 42 are married, and that is it. We don't have any missing data, so our percent and our valid percent are the same. Suppose we have our missing data, then suppose we have a missing data, valid percent will be used instead of percent. So now we'll do for age, and then you notice what happens. Frequencies, we uncheck marital status, you put the age, and then you see that it's giving us a lot that it's really not informative for us while analyzing our data. So what we are going to do is that we are going to kind of group our ages, make it a range that's from whatever value to another value, from the first value to another value. So this is how we're going to do it. We go to transform, We'll go to visual binning. Okay, so I think I've already done this before. So let me delete that column so that it will be okay. So I've already grouped it before, but let me delete it so that I show you guys how it's done. All right. Let's go back to our output, and we go to analyze descriptive statistics, sorry, we want to group them. So go to transform first, visual binning. We put in our age inside the box for variables to bin. We press continue, and then this shows up on our screen. We name our bin variable age cats. Make sure not to put a space in between this, because if you do that, it's not going to show. So just know that you're not supposed to put a space. Just whatever you're doing, whatever name you want to name it, let it just be together. And you make your cut point. So as you click on make cut points, then I want mine to start with less than 20 years. So my width should be 5. I just want you to have in mind that this I'm doing is going to vary for whatever you're doing with your age. So when you want to kind of put your age into a range, you have to know how you want to start it. So the end point of what I'm saying is that this is going to change. This is not going to be fixed. This is going to change depending on how you want to make your the range of your ages. So I'm just telling you how to do that. This is apply. Then we make labels, and you can see that less than 20, 21, and to 25. So any of my respondents that is less than 20 years will be in this place. So this is exactly what I want. And then I click OK. It's showing me binning specification, we create one variable. I press OK. And then let's go back to our main sheet. And then you see that our age cut shows in our column, age cut. So we've done that. So now we run the analysis for age cut instead of ages now. So we go to analyze, we go to descriptive statistics, we go to frequencies, we remove this, then we look for the age. So age in years binned. That's how you know it's that it's going to have a binned in brackets. You put it in, and then you click OK, and then it shows this exactly what we saw in our report. So it's showing that 19 persons are less than 20 with a percent of 12.7, valid percent of 12.7. Remember, we don't have a missing value, and so we take we can take either a percent or valid percent. If we had a missing value, we take our valid percent. Okay, I don't think you guys are seeing my screen. It's my output is showing now. Okay, yes, it is. So back to what I was saying, we are saying that 19 persons are less than 20. And so our percent will be 12.7, and then our valid percent will be 12.7. 29 persons are between age 21 to 25. Percent 19.3, valid percent 19.3. We don't have any missing value, so we can take either the percent or the valid percent. But if we have a missing value, we take the valid percent instead. So that is that. So I think we'll go back to our PowerPoint. Slideshow. All right. Okay, so we've moved into the concept of mean, median, and mode. And I believe that this concept is not new to us. So far we did maths while we were growing up. So this is just simply mean is also known as average, and it's the sum of all values in a variable. divided by the number of variables. And then I gave a very simple example of 2 plus 2 plus 4 plus 8 plus 4, and then divided by that. This is 20 divided by 4 will give us 5. So this is just a simple mean. Okay, so before I'll go into the median, I would like to, though not in this slide, I would like to mention that the mean, it's not robust to outliers. What are outliers? Outliers are those values that are far away from the distribution. So the mean, they are not robust to outliers, but the median is robust to outliers. Let me see if I can write on the screen so that you understand what I'm talking about. Text. I think I want to text. Okay, say we have these numbers. Let me get it from my. Okay, say we have these numbers. 2, 3, 6, 4, and 5. I want to calculate the mean. And okay, we have another number. It's another set of numbers. We have 0, 1, 4, 5, and 10. Now, if you look at this, I'm just giving a simple example. If you look at this, okay, so if you look at this, you see that these numbers, these particular ones, the one up, the set of numbers up, are kind of tightly closed, like tightly packed together. And then the set of numbers below, the 10, that's the last digit, is further away from the 0, 1, 4, and 5. So for this simple example, we can say that 10 is an outlier. And then for this simple example, we can say that this range of values are tightly packed, while this range of values, they are not tightly packed because this 10 is making it an outlier. So now we want to get the mean of this. I think the mean will give us, what did I calculate? I think the mean will give us 4, as 20 over 5 give us 4. And then the mean of this one too will give us 4. Now, let's take the median. The median is the median number arranged in ascending or descending number. So we'll go with 2, 3, 4, 5, 6, and here is 0, 1, 4, 5, and 10. So this is 0 plus 1, 1 plus 4, 5, 5 plus 5, 10, 10 plus 4, 20. Okay. What do I want to do? Okay, from here we can see that the middle number is 4, and then the middle number for this one is also 4. But what I'm trying to say here is that if you, okay, probably when we get to skewed and normal distribution, you see that because of this 10 here kind of drag the data, the distribution of data to its to the right side of the distribution, and then this is going to still remain in normal distribution. But let's just leave it. When we get to a normal distribution and skewed data, I will bring up this again for better understanding. Undo. All right. Okay, so let's move on. Why is my okay? So the median. Let's run the mean in let's run a mean using a distribution. Okay, so let's use this sheet. I don't know if you guys are seeing my sheet. No, that's not showing. Okay, it is now. Okay, so let's run the mean using this our distribution we've started with already. Let's say we want to know the mean of those. Where's my cursor? Okay. Nice. Untitled. Thank you. Don't you? Okay, let's say we want to know the mean age. So to do that, we go to analyze descriptive statistics. We go to frequencies. We put in our age. Now we go to statistics and we put in mean. Mean usually goes to standard deviation, and I'll explain that when we get to a normal distribution and skewed data. So continue. Here we don't want our frequency table to be displayed because we're not looking for numbers, we're just looking for the mean. So press OK, and then just let me share my output. It's showing now. I don't think it is. Let's try again. You share. Okay, it says now. All right. So this is our output. Mean, that's the mean age is 27.74, and our standard deviation is 6.943. That is the mean age for that distribution. So the standard deviation here is kind of telling you the spread of the entire data. That is, this 27.74 is the best estimate we can get. But then if you want to kind of factor in the spread of the entire population, you not say plus. That's why we want to put plus or minus. You're saying either it's plus 6.943 or minus, that's this 27.74 minus 6.943. Let me take that to you. This mean when we run our statistical analysis, this mean we get 27.74 is the best estimate we can get. But the standard deviation is kind of telling you the spread of the data around the whole population. And so since we've gotten a best estimate, factoring in other we are going to factor in the fact that this population could be 27.74 minus 6.94, or it could be more. So this standard deviation tells us about the spread. I will come back to it too while we move forward when we talk about measures of spread. Okay, so let me run the analysis again. So this is analyze, this is descriptive statistics, this is frequencies, age is, okay, let me uncheck age. We'll put in age again. Okay, in fact, let's do for the level of education, the mean for the level of education instead. Statistics, mean and standard deviation is already checked. We uncheck display frequency tables, we click OK, and then here it's telling us that the mean is 2.4, and then the standard deviation, that is the average persons who have that's the average level of education is 2.43 with a standard deviation of 1.131. Okay, so that is that. Let's move to our PowerPoint. Okay, so go to the median. The median is the middle number in a given set of variables arranged in an ascending or descending order. In a given set of values with an odd number of values, the median is usually a single value, whereas a given set of values with an even number of values, the middle value is gotten by adding the two middle numbers divided by 2. Let me see if I can annotate text. Let's say, okay, previous example I gave, he said median 0, 1, 4, 5, and 10. So if you look at this, this is an odd number of distribution because we have five digits. So our middle value is going to be 4. Let's take another example of 0, 1, 4, 5, probably 7, 10. So this number of values here are 6. So our middle number is going to be 4 plus 5, which is 9. 9 divided by 2, which is equals to 4.5. 4.5. So that is our median value. 2 here out, 2 here out, 4 plus 5, 9. 9 divided by 2, 4.5. Okay. Please, can I know how this why is my screen not changing again? Okay, so this is suppose, okay. So this is another example, arranged in an ascending order. We always know that your median should be arranged in an ascending or a descending order. So this is example 2, 7, 6, 4, 3, and in an ascending order, we said 2, 3, 4, 6, 7. And we got 4 as our middle number. Then here is example 2, 10, 6, 3, 8, 2, 5. In the descending order, it is 10, 8, 6, 5, 10, 8, 6, 5, 3, 3, 10, 8, 6, 5, 3, 3. And then you can see that this is an even set of numbers because there are 6. So we did 6 plus 5 divided by 2 gave us 5.5. Okay, so now I think before this, I want to run the median using our data. Okay, to run our median, say analyze descriptive statistics, frequencies. Okay, let's choose marital status. Statistics, you can check mean because we don't want mean again. But then the thing is that you can run the analysis together. That's all of them. You can check, you don't need to do them one by one, but I'm just doing them one by one so that you understand. Probably after I'm done doing them individually, we'll run them together. So this is median. This is quartiles. Quartiles is going to divide your data into, okay, maybe we should use percentile to say 25, then 75. Click on continue. We don't need a display frequency table, so we just say okay, and let me share the output. My output showing my output. Okay, so this is our median. Our median is 2, and then our percentiles, our 25th percentile is 2 that's 2, and our 75th percentile is 3. So now I think to explain these percentiles, let me go back to the PowerPoint. Okay, so when we talk about median, it is necessary we also talk about percentiles. A percentile is the number where a certain percentage of scores fall below and above the number. It explains the relative standing of a value when compared to other values in a distribution. A median is the 50th percentile, and this 25th and 75th percentile is telling you the values. That's the 25th percentile is telling you the values below the 50th percentile, and then the 75th percentile is telling you the values that are above the 50th percentile. Okay, so let's take this example. You got 120 marks out of 20, so after 200 questions. Okay, let's say you took an exam. Recording progress. You took an exam, and in the exam there were 200 questions, and you got 120 out of the 200 questions. So now, you knowing the individual score can be important to you. Yes, it's important to you, but then you want to know where you stand, where that your score stand when compared to other classmates that wrote these exams with you. So you know your score, that you have 120. But now, if you want to compare my score to another person in the class, where do I really stand? So that is the importance of percentiles. So now, you said this your 120 is expressed in when expressed in percentage, it is 60%. What does this 60% mean? This 60%, okay, let me draw a box plot and draw. Can I draw? If I can do. Okay. Let's see. Pardon me. Okay, so this is our 50th percentile. So sorry, but this is going to be a bit horrible. Try my best not to make it horrible. Okay, so I don't want to draw it. I want to text. So here is our 50th percentile, and the one up is our 75th percentile, and the one below is our 25th percentile. So now, okay, probably if I explain this example, let me explain this thing. So this 50th percentile, now, if someone is at the 50th percentile, it means that 50% are below this, that's are below this 50th mark, and then 50% are above this 50th mark. So now what am I trying to say? If you got 120 marks now out of 200 questions and your percentage is 60%, this means that you did better than 60% of the class that did that test, and 40% did better than you. If I want to explain this in simpler terms now, let's say it means that there are people who scored lower marks. You scored 120 now. Somebody who scored 110 definitely will have a lower percentage than you did. And then somebody who scored 140 obviously will have a higher percentage than you did. So now out of everybody that took that test, you got 60%, meaning that all those people that got 58%, 53%, 40 something percent, you did better than them. And then the remaining 40% of the class that scored marks higher than you did better than you. So the 60% is more like a reference. 40% did better than you, and then you that got 60%, you did better than 60% of the class that took the test. Let's say the income of a region is, say 50% of that region earn 45,000 naira. It also means that 50% earn more than that 45,000 naira, and 50% earn below that 45,000 naira. So so when we talk about median, we usually use median in a non-parametric data for better representation of the values. Okay, that is what I was trying to explain. That if we use mean for a non-parametric data, it's going to give you a false representation of that data. Why? Because the outliers in that distribution will drag the mean to the part, that's to the side of the distribution that has the larger value, or it will drag the mean to the part of the distribution that has a lower value. So if you want to have a good representation of the values, the median it better represent that values, because the median is the middle number, and so these outliers would not really have effects on the median. Now the IQR is interquartile range, and IQR gives the spread of the data at the 50th percentile. Let me annotate. Let's say our mean is 2.74, and then interquartile range, inter means between two, and then quartiles is percentiles that are expressed in percentages. You can also say percentiles become quartiles when they are expressed in proportion. Quartiles become percentiles when they are expressed in percentage. So now in our 25th percentile, we have 1.70, and then in our 75th percentile, we have let's say 3.75. This 1.70 to 3.75 is giving you the spread of the data around this 50th percentile. That is why when I said earlier that if mean income is 45,000 naira, then 50% are earning, I say if the median income is 45,000 naira, then there are percentages, that's 50% are earning above that 45,000 naira, and 50% are earning below the 45,000 naira. So when you say 45,000 naira, it's really, you don't really just say that the median income is poor. You have to check the spread of the distribution around that median, and that is the essence of this AQR. The AQR will give the spread of the data at the 50th percentile. I don't want to annotate it. Okay, so the mode. What are we talking about in the mode? The mode is the highest occurring number in a distribution, and a distribution can be bimodal, unimodal, multimodal. And let's say okay, let's take this example: 222155277. You don't need to arrange it. You just know that the the highest occurring number here is 2. This is measured of the highest occurring number here is 2. So in let's say you take your data from a population, and then you notice that while in that while you were checking, that's running your analysis, you notice that there is a cluster around probably people that have these illnesses at an earlier age, and people that have these illnesses at a later age. That's during the early infancy and late infancy. And then the middle of the distribution, it's not really okay. Let's say this a disease now occurs more at an early age and during the old age. So that distribution is bimodal because there will be increased number at the early age and there will be increased number at the later age. So this is the mode. The next is measures of spread, and I think that will come in a later video. So let me quickly show you guys how to run everything at once. This analyze frequencies. Let's check for age. Uncheck age. Go here. Statistics, take mean, median, mode, percentage. You can, instead of percentage, you can also take quartiles too. Then you check for the median, then you take standard deviation, continue, and this is okay, and everything shows. So yeah, our median is 27.74. I mean, our mean is 27.74 with the standard deviation of 6.943. Our median is 28.0. Mode, you can see that multi-modes exist. That's the A on top. And then that is basically, okay. I don't think you guys are seeing my output. All right, so this is it. Median 27.7, mean 27.74, median 28.0, the standard deviation 6.943 with our percentiles at 25th percentile, 50th percentile, and 75th percentile. So that is that for our mean, median, and mode, and I hope